Hello student, in this video I would like to show you how to calculate the basic reaction forces. So basically we have three basic type of supports, and based on three basic type of support we will have different kind of reaction for each type of support. So the first one is roller. So for roller we have only one reaction over here. For the pin support we have two reaction. For the fixed support we have three reaction. So two forces and a moment. For example, we have a simple beam over here with this one is a pin support and this one is a roller support, and I would like to put some load over here. So for example 7 feet from the left hand side I put 10k load, and 13 feet from the right hand side I put another 16k load. So let's solve for the reaction in this case. So the first step you need to do is to simplify the structure on the previous slide. So I simplified the structure in the previous slide into a free body diagram over here. The next step you need to do is to put all of the reaction you can have in this free body diagram. Okay, so for example at B we have this is a roller, so we have only one reaction. So I just call this one BY. At A, this one a pin. So on the previous slide I mentioned that this one have two reactions, so I just call this one is AY and AX. Now we need to solve for the reactions, which means we need to solve for AX here, AY and BY over here. So first, before you do anything else, what I want you to do is to write down the three equilibrium equation. Sigma Fx equal to 0, sigma Fy equal to 0, and sigma moment equal to 0. The next step, before you start writing the equation, what I want you to do is to write the sign for each of the equation over here. You can select any side you want. Usually I select the side, the positive side that is aligned with the reaction force over here. So I will have the reaction force with the positive value in my equation. It can simplify the calculation a little bit. So I select from left to right for sigma Fx. From bottom to top is the positive side for sigma Fy, and counterclockwise is the positive side for the moment. And now you can plug in all the variable with the value and calculate for each of the equation over here. So first for the Fx, we see over here we have 5 forces. We have AX, AY, 10k, 16k, and BY. And on the x-axis over here we have only AX, so that's why I write only AX over here. So from this equation we can solve that AX equal to 0. Now we only need to solve for AY and BY over here. So let's use the second equation. So for the y direction we have AY over here, and because the positive side is upward, so AY, I just put AY with the positive over here. And then we have BY, this one also positive. This one is downward, so this one is negative, so I put 10k over here, that's a negative. and the next one is 16k, so I put 16k over here. So this equation can be simplified like ay plus by equal to 26k. Because we have two variables and we have only one equation over here, so we cannot solve for this equation. So let's go to the third equilibrium equation. So this one, before you start putting the variable and the value, what I want you to point where you want to calculate a moment. So I can select any point in the beam over here, because this beam is static, so which means any point over here will have a moment that equal to 0. However, usually to simplify the calculation, I select a point that I can cancel some reaction force, so I don't have to calculate for that. So in this case, I can select A, so I will write A over here. And now I can just adding all the input and all the variable into this equation. So first, I want to calculate utilizing By over here. So the force is By. The distance over here is 7 plus 8 plus 13. That's gonna be 28. And so By multiplied to 28 will be the moment of By in the point 8 over here. Alright, so the second part I'm going to be using this force over here, 10k. 10k multiplied to the distance will be 7. And because this one is clockwise, while the positive side we select over here is counterclockwise, so that's why the sign over here need to be negative. Similarly, we have 16 multiplied to the distance is 7 plus 8 gonna be 15, and the sign over here also is clockwise. Is why the positive side we select over here is counterclockwise, so that's why that is negative. Simplify this equation, we can solve for By equal to 11.1k. Now we have By is 11.1k over here. We can plug in this one back to the second equation over here, and we can solve for Ay. So Ay equal to 26k, subtract to By, and By now is 11.1k. So we have Ay is 14.9.